Hi everyone, welcome back to our machine learning session. So previously we are discussing about types of machine learning, right? In the previous session we discussed about supervised learning. What is supervised learning? What are the different categories like classification and regression? In this session, I'm going to discuss about unsupervised learning. If you see the simple example for unsupervised learning is, it is a data-driven identify clusters. So what is cluster? How to identify clusters? With simple example, we'll see. If you see unsupervised learning, it is also a type of machine learning where the algorithm given data without explicit instruction. What exactly without explicit instruction or what to do with it? In other words, the algorithm is not provided with labeled output. We'll see with simple example here what is exactly unsupervised learning. Here in the slide, I am giving the definition, right? Without explicit instructions. Without explicit instructions. Are simply without labeled data. Without labeled data. If you remember our previous session, while explaining supervised learning, I explained this example, how to identify whether it is a supervised learning or not. So I have given a simple example. To identify supervised learning, which should contain input and output, that is features and label. And out of this, if it is yes or no type or very limited values in the output, we can say it is a classification. If it is continuous values, then it is a regression. But what is exactly unsupervised learning? Unsupervised learning. Here, opposite to supervised learning, here we are having only inputs. There is no labeled data. There is no labeled data. Means there will be no output, only inputs are nothing but features. Usually in machine learning terms, features and labels, features are nothing but inputs and the label is nothing but output. And also we will call these features and inputs with the different terms, like features are nothing but independent variables, and output is nothing but dependent variable. What do you mean by independent variable? And independent variable means, for example, I wanted to predict diabetes prediction. If you see, these are the input during diabetes, right? These are the features like glucose, blood pressure, and skin thickness, and outcome will be whether yes or no, diabetes, yes or no. Here, these are the independent features. Means each patient having the different features like corresponding glucose, blood pressure, skin thickness, insulin, BMI, age, and so on. Based on these features, I am going to predict whether the patient is diabetes or not. Means in order to predict this outcome, so this output variable, whether yes or no, in order to predict whether the patient is having diabetes or no, I need to depend on the input features. That's why this is a dependent feature. So label is called as dependent feature. Why we are calling dependent means it is depending on the input features to predict the final outcome. And these are the independent features, means each patient is having its own features like glucose, blood pressure, skin thickness, and so on. So these are different for different features, different patients, and based on these features, we are predicting final outcome. So this is called as a dependent variable. But here in unsupervised learning, we will have only inputs. We will have only inputs. There is no outputs concept. Then how to predict the feature data? Here I am having only inputs. How to predict the feature data? My aim of machine learning is, if I give the input and I have to train my model, in future if I get the input, I need to predict the future output. That is my target of my machine learning. Here I have only inputs. Based on the inputs, I need to train my model. But how to predict the future data? Here there is a concept called as clustering. Don't worry about clustering. We are having multiple algorithms for machine learning in clustering. We'll discuss all those algorithms. But here I will give the basic example how the clustering will happen. But later, when we are going to discuss clustering algorithms, we are going to discuss multiple use cases. We'll see what is clustering, how to discuss, means how to apply clustering on various use cases. We'll see with an examples later. What is clustering? We'll see with the simple banking application, how to do clustering. And in practical, we'll see later sessions. Let us take some simple banking application. Let us assume XYZ bank came and bank manager, they given a project where we have to design loan approval system, loan approval system loan approval system. In this loan approval system, what he is giving the input is only input variables. Here he mentioned only input features like what is the age of the customer, how much loan they have taken, whether they are paying regularly or not, and what is the salary of the employee who taken salary of the customer who taken the loan. Like this, only input features, there is no output is given, like whether to approve the loan or not, there is no output is there. Only based on these input features, I need to design a system where in future if I get this input, I need to predict whether to sanction the loan or not. This is my task. Let us see this example. So let us assume I have 1,000 customers in my bank. So 1,000 customers in my bank. So 1,000 customers. So out of 1,000 customers, let us take, I have classified into 4 clusters. What are these clusters? I will tell you. So cluster A, cluster B, cluster C, cluster D. There are 4 clusters. So cluster A, the features are like cluster. First, what is the meaning of cluster? Grouping the similar elements or similar customer, similar values. Here, that grouping, I'm giving general assumptions, but in real time, we can apply machine learning algorithms to perform the clustering. We'll see with the various use cases in the later sessions. Let us see cluster A, where the age group is between let us assume 25 to 30, and salary of the customer is between 30K to 50K for every month, 30K to 40K every month. And here 90, let us assume salary and paying regular or not. Here 95% of the users, they are paying the loans regularly. So let us assume 95% of the uh, customers, customer loans, they are paying regularly. So let us assume this is the cluster A. So cluster A. So let us take cluster B. So how to group these values, we'll see in later with practicals. Just assume. So these are the 31 to 35 customers. Age is 31 to 35 and salary maybe 45K to 50K around this. And let us assume 50% of the customers paying the loans regularly. And similarly, cluster C, and assume age is 36 to 40, 36 to 40, and salary may be 60K to 70K. And here only, let us say some 75% customers, they are paying the loans. And let us assume cluster D. And here this age is some 50 plus, and salary may be 80 plus, 80 plus, and only 10% they are paying the 10% customers, they are paying the loans. But this is the basic grouping has been done based on their historical data, who are paying the loans regularly and what is their age and so on. If you see, this group is non-risky group because 95% mostly they are paying the loans. This is a non-risky group. If you see only 10% they are paying the loans, it is most risky group. Most risky group. And here 75% they are paying the loans, somewhat risky group. Not high risky group, but is somewhat risky group. It is 50% they are paying the loans, semi-risky group. Let us assume like this. Now, if a new person came and apply the loan. Let us assume new person came and applying loan. Age of the person, let us assume 26, and salary may be 32K. This is one record. So something, let us assume Rahul came and applied loan. And here there is one more record. Let us assume age is something 55 and salary is 89K, something like this. Now I need to whether I need to sanction the loan or not. What it will do means it will find, means my algorithm, what it will do, it will find in which group it will belongs to this record. So this record belongs to which group? So whether it will belongs to A group or B group or C group, it will find in which group it belongs to. If you see, this is the matching group. It is matching to A group. So if you see, this is matching to this group. So this person is matching to this A group. So mostly this is matching to A group. So what it will do is belongs to cluster A, belongs to A. It is non-risky group. Sanction the loan. Sanction the loan because it is a non-risky group. I can sanction the loan. Same thing. If you see this new record, so this new record, so again it will calculate the distance between all these things. So it will calculate the distance between all these groups. And it will check which group it belongs to. So here it is clearly indicating it is belongs to group D. Group D. So it is highly risky group. Highly risk is there. So what my system will predict is don't sanction the loan. Don't sanction the loan because it is mostly risky group. Like this, first I need to group the elements, group the records. So if I get only input data, first I need to group the data. After grouping the data, then I need to divide that into clusters. And if I get a new record, first I need to calculate in which cluster it belongs to. Based on that, I need to identify the final outcome. So please remember this difference between two types of algorithms. Supervised learning, where you have both inputs and outputs. And in unsupervised learning, you are having only inputs. This is the main difference you need to remember. Supervised learning, both inputs and outputs. So if you know, if you are able to categorize your input, data set, then you are good to go which algorithm to use. Unsupervised learning, here you are having only inputs. Again, in supervised learning, means if you anyone missed my previous session, just watch my previous session on supervised learning. If it is of type 0 or 1, yes or no, or few limited values in the output, few limited values, then you can say it is a classification. And if our data set consists of continuous values in the output, continuous values, then it is regression. Yeah, that's it all friends about unsupervised learning. Regarding practical, we'll take a separate sessions while explaining with use cases. I will show you completely how to design supervised and unsupervised models. Thanks everyone. That's all for about unsupervised learning.